So today we're going to be solving exponentials and seeing how we can use what we've already learned to do that. Before I get into the actual process about how we do it though, I do want to deal with how we don't do it. Because every now and then I see somebody who looks at this and they think, oh, divide by 8. But that doesn't work. Because this is not 8 times x equals 80. This is 8 to the power of x equals 80. And that makes all the difference in the world about what we can do. So we need some sort of a function that is used to calculate an unknown exponent. Because of course there can only be one number that x can possibly be. 8 to the power of something equals 80. And it's going to be some ugly decimal. So thank goodness our calculators can do that. In fact, the function that exists entirely for figuring out what exponents equal is the logarithm we've been dealing with. Because log, remember, equals the exponent. That's why in this case when we write it as a logarithm it equals x. That's why log exists. Log exists to calculate the value of an unknown exponent. So on your paper you wrote the original problem. You've hopefully written that work already. And then from what we did last week, you can now calculate what the value of log base 8 of 80 is. So please do so. Calculate what this is going to give us and show the work that you're doing to get it. So when you do log 80 divided by log 8, you should be getting an answer of about 2.11. And so notice then, we've now solved this. We know what x equals. Little side note, detail-y stuff. The reason why I'm rounding to 2 decimal places here is because we are told specifically to round to the nearest hundredth. So always look to see what you're told to round to as you do these, because I'm going to be changing it up on you as we go. All right, now I'm going to take a little sidestep into a different part of the process, and then we're going to come back to solving these exponential equations again here towards the end of the lesson. So before we go there, I'd like you to take some notes down. Write down everything up there. You'll find that by having all the little notes that I put around the equation, it's going to make your life a whole lot easier in the long run. All right, and then a few little tidbits about this equation, things that you're seeing up here. A of t is just kind of the generic, okay, this is what it's going to tell us. It's our final amount. This is a big one up here for the r value, and it's one that tends to cause people a decent number of problems. Because you notice that r has to be written as a decimal. And so in order to turn a percent into a decimal, the process is always the same, but different people remember different ways. You would either be remembering divide the percent by 100, or you'd be remembering move the decimal place over twice. Now, if you didn't remember when you first saw this how we turned 5% into 0.05, I would suggest you make note of that as well with this so that you'll remember. And if you're making note of it, the easiest way I think to remember, divide by 100. So take your percent, divide it by 100 to turn it into the decimal. All right, then the p-value stands for principal. Principal is just a fancy technical term for the starting value, the starting amount. And number of time periods, the most common time period that you're going to be seeing here is years. So you could really note this as being the number of years, but because the same equation can apply to other time periods, we leave it a little bit more generic than that. Now we're going to see how this applies to an actual word problem. So for this word problem, I would suggest that you start by writing this problem down on your paper. I'm going to give you a little time to do it. Write it all out. Yes, you can shorthand a few things, but do not do so to the point where the meaning gets lost. But I want you to have this down so you have something to tie the equation and the work that we do to. All right, then once you have it written down, let's take a look at how we actually then use this information to start building our equation, and then we can use the equation to find the answer. Now, this is one of those problems where it's increasing by a certain percent every year. Therefore, I'm going back to the equation that we just wrote down. Anytime something's increasing by a given percent every year, month, whatever it is, you're looking at exponential growth or exponential decay. All right, so when I go to write this equation, first up, we start with a of t. Okay, so we got a of t equals. First thing we put in then is the p value, our principal. What is the value of the principal in this problem? 500, yeah, because P, the principal, stands for starting amount. So we start by putting $500 in this account. And like a typical savings account, it's not paying us very much. It's paying us 0.25%. But when I put that into the equation for R, it's not going to be 0.25. Because notice 0.25% is a percent right now. And while it has a decimal in it, I still have to turn the percent into decimal form. And so, divide it by 100. You should get 0.0025. And so again, that big idea is anytime we are writing this equation, to get your R value, you take whatever your percent is and divide it by 100. All right, next up, I got to put in the T value. What is the value of T in this problem? 8, because this is 8 years. Now notice though that when I plugged the 8 in for T here, this was no longer at that point A of T. I then changed it to A of 8 because I'm plugging 8 in for T. When you plug T in one place, you have to plug T in both places. Make sure you have that equation written down before we go forward. And then we're going to see how to use this equation to find our value. Now the first thing I would suggest doing when doing this work, go ahead and do that addition that's inside the parentheses. So 1 plus 0.0025 gives us 1.0025. That's the number I'm actually raising to the power of 8. So that's what you'll do. You'll do 1.0025 to the power of 8, then multiply that by 500, do that calculation, and let's see if we get the right number out. We want to make sure we can. All right, so you do the 1.0025 to the power of 8, multiply that by 500. You should be getting an answer of about 510.09. Notice I chose to round to 2 decimals. This one did not specify what to round to. So does it matter in this case? And in this case, yes, it does matter what we round to because this is talking about money. If we're talking about money, we always round exactly the same. We round to the nearest cent, which is the hundredths place. So we always want to go 2 decimals when we're talking about money. So then in this case, our final answer is $510.09. All right, so now let's take a look at a variation of this. So now suppose that your account decreased in value by 0.25% each year. Write the equation and figure out how much there's going to be. By the way, if you're ever offered a savings account and the interest goes down every year, probably not a good account. All right, so how would we change it? Well, if we start by taking a look at what the original one was, we can actually make one small little tweak to show that we're decreasing by 0.0025 instead of increasing by it. And that is, you do 1 minus 0.0025 instead of 1 plus. Basically, it's like the rate is negative because it's decreasing. That's why we subtract it. All right, so now knowing that, go ahead and fill in the rest of the work. Do that calculation, figure out what we're going to get as a final answer for this one. So first thing when you do this work, go ahead and do that subtraction. So that gives us 0.9975 to the power of 8 now. Do that exponent, then multiply by 500. We should get 490.09 or $490.09. One little note about this, just to be clear, our original problem ended up as 09. This one ended up as 09. That's pure coincidence. That's not a pattern that you can observe for future reference. That's not something that's going to happen every time. It was just coincidence in this particular case. Now, this equation that we've been using here, this situation that we're representing, especially the first one where it's actually increasing, you've heard of compounding interest. This is compounding interest. Compounding interest is a form of exponential growth that is common to investments. And so we're going to keep practicing this over the next few lessons as well. I'm going to give you 1 or 2 problems like this each day until you're fairly experienced and comfortable with them. And then we're going to integrate that with solving even more. But because solving is important, and that's kind of the big theme I need you to leave today completely mastered on, we're going to do one more solving problem. The first problem that we started class with today, we solved an exponential. We solved a fairly simple exponential. Now, you're going to solve a not so simple exponential, because if you can solve the tough one, the rest are going to be easy. So this is probably about as complicated one as you're going to see, because it has almost every possible transformation we could put into it. But we really are going to approach it the same way we've approached other problems. The key at the start of doing one of these is just knowing what our first goal is. Now, since we're going to be turning it into a logarithm to solve it, and I know I'm doing that because the x is in the exponent, that means I need to get the exponential part by itself. The exponential part is whatever number it is raised to its power. So that 3 to the x minus 1 is going to be by itself as our first step. So that means I got to get rid of the 2, and I got to get rid of the minus 8. Well, technically you could do either one of those first. I do find it much easier to get rid of the addition and subtraction first. So I'm going to move the 8 out of there. Step 1, add 8 to both sides. Now I said we're getting rid of the addition and subtraction first, which is why we're moving the 8. Somebody's probably wondering, yes, but we're also subtracting 1. Can I get rid of that? No, because it's trapped in the exponent. And I'm not going to be able to get it out of the exponent until I do the log process. All right, now that I've done that, I now need to get rid of the 2. Notice it's 2 times the 3 to the x minus 1. So I'm undoing a multiplication by 2. All right, great. Divide both sides by 2. Having done that, we now have reached our first goal, which was to get the exponential part by itself. And again, the reason why we wanted to get the exponential part by itself is because I can now turn it into a logarithm. So we now rewrite this in log form. So it's going to be log base. Well, the base of the logarithm is whatever's raised to the power. So in this case, that's going to be a 3. The next number that goes in is the number that the exponential equals. So that's going to be the 64. And log always equals the exponent, remember. Our exponent here is not just x, though. Our exponent here is x minus 1. That's okay. We still put that in as what the log equals. And so then I'm going to go ahead and write this as x minus 1 equals log base 3 of 64. If you wrote it as log base 3 of 64 equals x minus 1, of course, that is the same thing and also works. Having done that, we're almost done. The log base 3 of 64, notice, that's something you can calculate. So start by calculating that value. And of course, like before, show the work of how you do it. So do that next. And so to show that work of how we calculate log base 3 of 64, I want to see you actually write log 64 divided by log 3. And then you can do that calculation. It should give you an answer of 3.7855. It's a decimal that just keeps on going and going. Now notice how I wrote it here. I didn't even bother to round it yet. I wrote 3.78 and then 3 dots. The 3 dots just mean this decimal keeps on going after that. Because I don't want to worry about rounding it at this point. You never round in the middle. If you round in the middle, you're going to give yourself problems. Maybe not on this problem, but it will cause you problems. So never round in the middle. So I'm writing down this 3.78 so that I can remember that it's about this. But on my calculator, as soon as I just did that calculation, my calculator has 3.7855. It has the whole decimal. At least as much as a calculator can display. I leave that on my calculator. For some reason, I'll see people who will write down 3.78 on their calculator. Then they'll press clear and type in 3.78. They just cleared off the extra decimals and typed in the rounded one. It was more work and it's less accurate. Just leave it on there. So then when we do our next step, which is get the 1 over, all you got to do is say plus 1. And then, since this is our final answer, this is where we'll do the rounding. So this is where I then say, okay, it was 4.785. Since that one next digit's a 5 or more, I do round it up, so that's why it's a 7.9. That is then our final answer.